near to the effluent standards, but still some cases further post treatment is required for the policing treatment before utilizing it. So that's why in case of utilizing it in our toilet flossing, we have gone for this sand filters. And here, so the Anamax in the pilot scale study, so the student has worked on the growth of the culture, the same from the this pilot plant. We have also collected the samples, and the samples have been taken to the lab, and it has been analyzed that whatever there is Anamax culture is there in the samples or not. And total nitrogen removal efficiency in the pilot plant has been obtained. So like partial nitration unit, we have aeration and non-aeration period, 4 hours, 6 hours. Alternatively, we have followed and we have seen that what is happening to this. So the total nitrogen removal efficiency maintaining different aeration and non-aeration combinations, it has been checked. So we have which indicates good combustibility of the biogas, and reduces the organic load in the wastewater. Methanization unit for the digital methane recovery we have done. So it increased the methane to 75 to 85% with increased energy recovery and usability. And the partial nitration unit prepares nitrogen for efficient Anamax process and reduces the aeration energy requirement. It is only a stirrer. There is no any diffused aeration was given. Only a steering action was done. And Anamax MBBR, then the highly efficient nitrogen removal efficiency we could achieve. So this is the pilot plant benefits we have got. This data is showing the methane, that biogas, what is the methane composition. So initially in the USP reactor, the methane composition is around 70%, which is increased up to 80%. That is the methane we have obtained from the demethanization unit. And again, this laws which I have shown you in the previous two slides, that is collected from the Anamax unit from the pilot plant, that also shown the Bucadia. So that indicates that is the Anamax based culture, but that Bucadia we have not seen in the partial nitration unit, but in the Anamax based MBBR. That indicates there is Anamax growth and which is also contributing to the removal of nitrogen. There is no claim that the nitrogen is only removed by the Anamax culture, because both nitrification, denitrification, as well as Anamax based nitrogen removal is happening in the system. So our aim is to check that whether the Anamax process is working or not. So further, the life cycle assessment of the pilot plant has been conducted, taking the whole plant as the system boundary and taking different units with the life cycle assessment. So the software used, we have taken the help of IIT Kharagpur for this, because we didn't have the software. Simapro, Professor Dubey, we have taken his help, and we have done this LCA study, taking the whole capacity of the plant, 100 meter cube per day, and what the energy and material input, included electricity, biogas production, sludge characteristics, all these things, and the output considered treated effluent, biogas, and sludge. So taking this, the LCA has been carried out. And this is the assumptions for the LCA study. So different assumptions has been taken in the study. So I'm not going to the detail. So this, the unit of pilot plant, what are the actual design life? We have estimated the design life depending on the materials used and depending on the equipment used in the pilot plant. Okay, so the different component, the lifespan, and different materials used. So that is the design life. It has been calculated, and quantity that has been used. Based on that, what are the electrical drivers? What is the power that has been utilized? That we have calculated. That is the cost, total power consumption cost. We have calculated in the different units. Then, and that Here, and total pilot plant it has been found, and in the summary it can be seen here the comparison, that is the normalized score we have obtained for the different units, the total pilot plant. The different impact categories, like which is contributing, like global warming is contribution from how much from the USBR, how much from the MBBR. So all these things, after taking all the considerations, so this has been presented. Then further, the techno-economic analysis of the pilot plant has been carried out, taking a total life cycle of 20 years, taking the costs, and we have the benefits. In the benefits, the methane gas which is being produced, that is 8.5 meter cube per day. The methane gas is produced. That is mainly. And I have told you in the beginning, the NMOX process is a less sludge producing process. Normally, in the activity sludge process and other nitrification, denitrification, lot of sludge is being produced. But in the NMOX, there is sludge quantity is very less. So that's why we are not able to capture any manure, any sludge is not present. So there will be no manure, very less quantity, 100 kg per year, which is negligible. But still we have calculated it is 3,000 rupees. And the treated wastewater, it is calculated that is 0.07 to 0.08 million liters per day, because we are feeding 0.1 million liters per day, out of which we can utilize this much amount of wastewater. So we have just checked that what is the water, at what rate we are buying, our institute is buying from the government. So based on that, if we are utilizing the wastewater, we have utilized, you might have seen in the photograph, we have a outlet point from which our institute, two outlet points are there. One is for collection in the tankers. We have a tanker in the institute which collect the wastewater, treated wastewater, and then we put it in the horticulture uses for different purposes, non-edible crops. And then we have a supply pipelines which is going to different points for horticulture purpose. Then the third line is connecting to the institute sand filter, so which can be utilized for the toilet flushing. So all this uses what quantity of wastewater is being used, based on that what rate the institute is buying the water. So we have calculated accordingly this much amount can be recovered from the treated water. So there is mainly two recovery from the wastewater. Major focus in the beginning, that in the decentralized system, how we can eliminate the use or reduce the use of fresh water. That also target is achieved. We have 70% of the wastewater is being utilized, and the gas production, that is some energy we can recover, that is also recovered from this pilot plant. So this is the recovery and the total carbon offsets, then avoid environmental damage, all these things, revenue and environmental gains. Says some additional treatment is required for completely utilizing the wastewater. But this is the discharge standards. We have standards for the uses, like we can use for the agriculture purpose, can be used for the toilet flushing. We have a different standard. So we have to match. So if it is not matching, maybe a sand filter or maybe a carbon filter can be given, or maybe a aquaculture pond, maybe something sometimes we can give, so that it can achieve the required standards for use. But now it is achieving, and we have a sand filter that is also fulfilling the requirement if you are sending it to the sand filter. Further, we have done the SWOT analysis, that is the strength, weakness, and the opportunities and threat. That analysis of the pilot plant that has been carried out. I am not going to the details. but only just mentioning the strength analysis, that is efficient organic and nitrogen removal we have carried out. Energy efficient system, because we have reduced the consumption of energy by eliminating two steps in the nitrification and denitrification process. And also energy is recovered by the biogas, that is the methane production is there also there. That is 8.5 meter cube of methane gas per day it is produced. Then the compact design, less physical space, environmental sustainability. So all these things are the strength of this pilot plant. Then there is certain weakness, that is the operational complexity. That is, we have to maintain the aeration and non-aeration period. So initially some knowledge is required how to maintain that aeration and non-aeration period. Also we need to maintain the pH initially. So that for the initial growth of the Anamox culture. So that operational complexity is there. We have to overcome that. So high initial investment, because we have to make some initial investment for the construction. So when you're going or planning for a decentralized facility, we have to see that whether we can go for this system in a decentralized facility, or we need to go for a centralized system. Then the Anamox inoculum, as I have told you, Anamox was present, but people are not able to identify it, but now it is being identified. So how precisely we can utilize the Anamox inoculum, how will be accelerating the growth of the Anamox culture, that is also important, because Anamox is slow growing bacteria. So we have to see that what are the practices we can follow, so increase the rate of growth of the Anamox culture. Okay, then the integration challenge, we can integrate with the different systems. Now we have used the USP, we can integrate with the ASP as well. Other systems we can integrate the Anamox culture or the Anamox process. Then the opportunities, that depending on the market demand, we have to reutilize the wastewater. So all these things, the pilot plant will be a good solution, that we have tried this Anamox system. And this a threat, that is the competing technology, because although it's a new system, but still we have other systems, existing systems, which are well established systems. If you go to the market and say that, okay, you take my system, it may not be initially acceptable, but still we have conducted one stakeholders workshop, where the Central Pollution Control Board, State Pollution Control Board, Bhubaneswar Municipal Corporation, and the Odisha Water Supply and Sewerage Board, people have participated, and they have also appreciated the system, and if possible, and if in future we may implement the system for the real scale applications. And so it is comparable to one of the best available technologies in the recent days, with this high the saving of energy and the production of the biogas, which is also that is good. And we can reutilize the wastewater, which was the main objective of this starting of the presentation. That is, mostly we can do the treatment for removal of organic as well as nitrogen, and completely it is a decentralized system, it can be utilized. But one difficulty in the system, that for the Anamox culture, or maybe for the USP system, basically high organic loading is required. Mostly the USP is held in case of the low organic loading, but in our case it has shown good result. But normally people adopt USP system in case of industrial wastewater, and that is one of the limitations. Also, Anamox grow in high nitrogen content. So that is also domestic wastewater. In Indian domestic wastewater, we find very less amount of nitrogen. So if you think of industrial wastewater, it may work very well, although it has worked good in our case. But for betterment of the result, better application, we can also explore in the industrial wastewater context, like in the industry, which is maybe fertilizer producing industry, or maybe the dairy industry, or maybe distillery industry, where there is a high organic loading, high nutrient content. So in those industries, we can try it, so to see how it works at a higher organic loading, higher nitrogen loading in that context. But still, this we have achieved TRL level 6 in Indian context, which was the target of the project in the beginning. And this is the conclusion, that is the summary of the informations. Already we have discussed all these things, like the methane recovery. is around 80 percentage. The annual methane recovery is 8.5 meter cube per day, and the estimated annual carbon offset is 62.68. And effluent reuse, also we could have tried like say 70 to 80 meter cube of day, so that 100 meter cube of day wastewater is being treated. From that we could able to utilize 70 to 80 meter cube per day of treated wastewater, which is a success. We could able to use for non-potable applications, the irrigation, that is the horticulture, that is non-edible crops. We have utilized it for the flowering plants, or maybe the other plants, the decorative plants. And integrated USP deaminification anomospheric MBBR serves as an energy efficient system for domestic waste treatment. So also I have not shown in the PPTs. We have also done a social survey, like how people take about the utilization of the wastewater. If we supply them the wastewater from this treated wastewater from our plant, whether it is acceptable to them or not. So we have conducted the survey in our campus in Bhubaneswar city and in Cuttack city. So from the results, it is people are aware that okay, they are now accepting. Okay, that is our job is to now accept the treated wastewater for use. And also, some cases we have found that they are ready to pay for the treated wastewater, because now supplied wastewater is they are paying. If you equal amount or little bit less amount or less cost, if you are supplying the treated wastewater, they are ready to use, ready to take the wastewater. That also we have done the survey. We have got the data, but I have not shown in this. So actually this project, we have several investigators. So Dr. Dipesh Parbe, he has already got his PhD a few months back. So he is the research scholar for this project. And Professor Manashwini Bera, so she is the principal investigator. The project is still continuing up to October 2026, but Dipesh has already got his PhD, completing the laboratory work, and we are now still operating the pilot plant. So maybe some data will be adding to this operational phase. And I am also one of the co-principal investigator along with Dr. Professor Pushpendra Bhuya from Indian side. And we have from the European Union, Professor Tabotano and Dr. Ivar Jaker. These are the co-principal investigators. So the Indian part is here, and the foreign people are standing here, the European partners, in front of the pilot plant. And I thank the organizing team of NIT Agartala for giving me this opportunity. So if I'll just try also to show a small video of our pilot plant before ending this one. Let me check whether I have or not. Just a minute. Let me just check. And so I'm not giving any sound, just a small. This is the view of the pilot plant. Just for your better understanding, I've shown you the pilot plant. So it is a big plant, and some difficulty in operating such a big plant. So any question?
Okay, thank you, sir, for a detailed discussion about Saraswati 2.0. We heard many times about the project, and we never know what is the IIT Bhubaneswar part. Thank you, sir, once again. So, any question from the audience? In our chat box, we received a question, sir, from Dr.
Can I ask,
Abhishek Mondal.
yeah, can I ask some questions?
Yes, please go ahead.
So, sir, we're talking about the wastewater treatment, and I want just query from that. What are the different type wastewater he had been checked in this IIT Bhubaneswar? Because he told that he had collected the wastewater from hostel only, and sir has told about that. This composition of wastewater where it contain a lot of the nitrogen, so there this enum of microbes can be work better. And he told some limitation about that this enum of microbes may be growing to slow rate.
No, actually, for this particular project, domestic wastewater characteristics. What are
No, no.
normally if you go to the municipality, that is domestic wastewater characteristics. But other than this project, we have some other projects also. So we have tried the wastewaters like brewery wastewater, distillery wastewater, rice mill wastewater. So different industrial wastewaters also we have tried. So my say is that actually, Anamax for Anamax growth, it may be favorable if we have higher nitrogen concentration. So, domestic wastewater has a very limited nitrogen concentration, although we have got a good result, but still, we can explore that okay, higher nitrogen concentration, higher organic concentration, whether we will be able to get a better result or not. But that is that is there. Possibly, we will get a better result, but we have to check that what is happening if there is a higher concentration of organics and nitrogen, what is happening.
So it means that it is the prediction, or you have any data about that? Okay, what would
No
be the
data
range?
I don't have, data I
Mhm.
don't have, but definitely because we are using a USP system that works good in higher organic concentration. Okay, so similarly the Anamax process the it may work good in the higher nitrogen concentration. So that is one of this maybe one of the facts we have to check.
So, once a small question about the NMX, this microorganisms. You told that once it had been work on that wastewater treatment, what are the main component going to be reduced on that wastewater? This how this NMX microorganism can be
Only
contributing.
nitrogen removal, only nitrogen removal we are focusing. That is
Mm-hmm.
the ammonium, whatever present in the wastewater ammonia that will be removed. Only focusing on because mostly the wastewater treatment, biological wastewater treatment processes focuses on the organic and nitrogen removal. So organic component is focused in the USP reactor and the organic carbon, and the nitrogen removal is focused in the anammox process, because normally in the active sludge process if you go to any wastewater treatment plant or STP, if you go, you will see you focus on the organic part only. And nowadays, people are being recycling the wastewater for removal of the nitrogen. But if you focus on the nitrogen removal as well, so some nitrification, denitrification process you have to do. Otherwise, this is an alternative process to nitrification, denitrification. That is the Anamax process for the nitrogen removal. Energy efficient as well as less loss production.
Okay, sir. Thank you very much. So one this demethanization, you have told that one of the tank is there, and are you using any filter? How is going to be remove the
No, it
methane
is a
content?
gas stripping mechanism, because the gas is dissolved in wastewater. We have
Mm-hmm.
simply used the gas stripping mechanism to remove the methane.
Okay, sir. Thank you very much for my answer. Thank you.
Okay, thank you, sir. So we received one more question from Dr. Abhishek Mondal. The question is, could you please elaborate a bit about the TEA in a stepwise manner, starting from what sort of economic data is required, what methodology had been adopted, how environmental benefits were converted into economic benefits, for example, CO2 credit, etc.
Can you fill the certificate? So actually, in our process, what I will say that in that ecological benefits or the environmental benefits, what we are talking about, first of all, what is the carbon footprint that you have removed from the treating wastewater? That is one, carbon nitrogen removal. So we avoided the discharge of wastewater to the water body. So in the terms of that pollution effect, I can't say right now what exactly has been calculated because I don't have the data sheet with me. But these are the things we have calculated. And the ecological benefits like you can because there is certain parameters like if you see there is certain parameters I have shown you in case of even LC analysis, different potentials for even all the different ecosystems. So certain things are there, certain parameters are there. So accordingly, it has been calculated. So for carbon dioxide, like all these things are available. The standard procedures has been followed, but I cannot say the details because I have not gone in details. And also this part, we have taken the help of IIT Kharagpur, as I mentioned.
Okay, thank you, sir. So any questions from the audience? Okay, Anindita, you can moderate the questions further received in WhatsApp group.
Sir, there is a question from Chandrasekhar. What is the retention time of the pilot plant?
As a pilot plant, we have a total 12 hours retention time, but we have maintained a aeration, non-aeration period in that way. Total 12 hours the retention time.
Okay. And another question is, does the NMOX process eliminate the nitrification and denitrification completely?
No, just I have told you, like we have achieved only 20% NMX growth. So it is a mixture of nitrification, denitrification as well as NMX process. So further we will focus on the total elimination of the nitrification, denitrification. But some part of the nitrification and denitrification has been eliminated by the NMX process.
Okay, sir. Thank you, sir. Is there any other questions from participants?
Hello, sir. Am I audible?
Yes, please.
Sir, namaskar.
But this NMX process 20 minus 30 degree conditions also they have checked applying it in our Indian conditions. So both the conditions it is working fine. So temperature variation in that context, if I will say, it is not affecting that much to the NMX cultures.